Well, we have a question here, question 5, where the question says, sketched below is the parabola f with equation f of x is equal to negative x squared plus 4x minus 3, and the hyperbola g with equations as given. Now, b is the turning point of f lies at the point of intersection, the asymptotes of g, and then a is given by negative 1, 0 is the x-intercept of g. Now, the question says, now we're going to do question 5.1. The question says, show that the coordinates of B are negative 1, 2 and positive 1, excuse me. I'm gonna write the question over here, question 5.1. I need to prove that the coordinate of B here, this is B. To prove that B coordinates are like 2 and 1. Now, the thing is, this B lies on is a point on the parabola. Okay, the parabola, the equation of the parabola is given by f of x equal to negative x squared plus 4x minus 3. So to prove that this point lies in here, we can substitute. Okay, we can substitute the point 2, 1. There will be like different ways to solve this same problem. We can, if the point 2, 1 lies is a point on this parabola, meaning it will the coordinates of b 2 and 1 will satisfy this equation. It means that if I sub in, okay, because this, remember that this is like the y value, okay, it's like y equal to negative x squared plus 4x minus 3. Now I'm going to substitute y by 1 and then x by 2, okay, I'll sub x by 2. So this is like 1 equal to negative x, so x squared, which is 2, plus 4x minus 3. Okay, this makes like 1 equal to 2 squared is 4, so negative 4 here, plus I meant to write 2 here. So it's 2 over there. 4 times 2 is 8, and then minus 3. So this will make what 1 equal to, if we do negative 4 plus 8 is 4, 4 minus 3 is 1, so 1. Because we have an equality here, we can say that B is a line of, I mean, we can say that B, the coordinate of B are exactly 2, 1. If they were not, you wouldn't have an equality over here. Well, this is one way, or someone else would like to, we can also use like, because B is a turning point, another way. Okay, I'm gonna say or over here, because B is a turning point, and right here, since B is the turning point, meaning at the turning point, at the turning points where like the value of x is given by on the right here, at the turning point 𝐥TP is equal to minus b over 2a. Okay, because we have quadratic equation the form ax squared plus bx plus c. Now in this situation, we can see that a has the value of negative 1, b has the value of 4, and then c has the value of negative 3. We can also do that, and then we can see from that 𝐥TP will be equal to minus b, so minus b, which is 4 over 2a. A is negative 1, so negative 1, and then this is equal, this implies that this means that 𝐥TP equal to positive 2 if you do this calculation, because this makes negative 4 over negative 2. That makes that 𝐥TP equal to 2. This is the 2 that we got here. Okay, now we can also substitute this again to find y, it's gonna be the same thing. Okay, you can sub 2 in this equation, and then in this equation, and then we get y equal to 1. So that's how we can prove it. We can move on. The following question is question 5.2. So previously we did 5.1. Now we're going to do 5.2, which says write down the range of f. Well, f is a parabola. Okay, it has an inverted U-shaped form. If they ask for the range, it means we just want to say the range cannot exceed the y coordinates of b. So over here, the range will just be y equal to, y must be lesser than or equal 1. Okay, because the range cannot be more than, the range are all the accepted y value. Okay, the highest, the toppest value here for this parabola is 1. Above 1, it's not in the parabola. It's not lying on the parabola, but it's only 1 and lesser than. Okay, someone else may write it like negative infinite lesser than x lesser than or equal to 1. Okay, that the range. The two are also correct. Question 5.3. And I'll move the board a little bit up there. 5.3, the question says, for which value or values of x will g of x be greater than 0? Now let's see g of x. We can see that g of x is this hyperbola here. Okay, now there are some values for x for which g of x is more than 0. It's all these values, because this is above. When they say more than 0, we look at the part of the function that is above, okay, the horizontal line, the y-axis. The y-axis is this one, okay, and we can see that this part here of g is above, okay, the x-axis, and this part also is above the x-axis. Now I will say then for here 5.3, I see here 5.3. So the values of x for which g of x is more than 0 are the values like x lesser than or equal to 1. I'm using lesser than or equal because over here it's greater than or equal. Okay. Otherwise, if it was just greater than, I'll say over here lesser than only. So x must be lesser than or equal to 1, and then we can see the asymptote. It has this other arm of the hyperbola has its asymptotes by this line. This line. It's happened that the asymptotes of g of x is also passes through the turning point, meaning 1 here. So actually, excuse me, 2 here. 2 is the x coordinate, yes, 2. So now we can say end. It's this one end, or we can say or x is greater than or equal to 2. So this is the solution. Yes, that's the solution. Okay. Values of x. So those two are values of x for which g of x is greater than or equal to 0. Now, the following question is question 5.4. The question says, determine the equation of the vertical asymptotes of the graph of h if h of x equal to g of x plus 4. Well, I'll write the question here. 5.4. We are looking for determine the equation of the vertical asymptotes of the graph of h. Okay, looking for the asymptote of the graph of h, but it is said that h is the same as g of x plus 4. Now we look at g of x is this hyperbola here. The arms of the hyperbola is there. Now, when they say g of x plus 4, the plus 4 here simply means that the same graph of the hyperbola is shifted 4 units to the left. Okay, maybe my left here seems to be right for you who's watching me now. Don't laugh, but it is so. So it's moving to the left. So now, meaning this over here we have like 2. Okay, the asymptotes, the vertical asymptote is here by 2. Now, moving 4 units to the left, it means we're going to minus 2 from 2 here. And then this will be, minus 4 from 2 here, I mean. So we minus 4 from 2. And then, which is equal to -2. So now it's gonna be like 0 is over here, another -2 there. So the asymptote will be somewhere there by -4. Okay, so now over here I'll say the vertical asymptote, which is the x value, x will be equal to -2 here, -2. Okay, because we do 2, this 2 minus 4, we get -2. So the vertical asymptote is by -2. Now, the other question is question 5.5. The question says, determine the value of P and T. Well, P and T are over here. Okay, they are part of the equation of the hyperbola. X is equal to x minus P, open bracket x plus T equal to 3. Now, okay, we will going to expand this, but a bit, okay, this way. I'm gonna move my board over here, and then we had like 5.5. Because of space, I'm gonna write it here. So we want the value of P and T. That's what we want to find. And then it is given that x minus P in a bracket like this, and then x, actually y plus T equal to 3. Okay, so now we need to determine the value of P and the value of T. Okay, and then it is said that this is an hyperbola. I already know that when I have an hyperbola, 3 here is usually the numerator, because hyperbola are the general form of hyperbola is the hyperbola is given by the form A over x minus P plus Q. Or sometimes the variable can vary. You can call it T, you can call it Q, or whatever it is. But let's use the Q, just the formula. Now, over here, I can transform this. I can move this part, the x minus P, to the other side of the equal sign. So this will be, I will be left with y plus T equal to 3 over x minus P. Okay, there's no need to put brackets here, but just for sake of illustration, I'll keep it for so long. Now over here, this can be just written as y plus T equal to 3 over x minus P. Then I can move the T on the other side. So this will be y equal to 3 over x minus P minus T. Okay. Now, we had the asymptotes because the P here stand for, this P stand for this one stands for the vertical asymptote. And then that other one, the T, stands for the horizontal asymptote. Okay. So now the vertical asymptote is the x value and that's the y value. Now, if I look at my graph now, I to identify the asymptotes. We had asymptotes at this point here, at the point where B is, because this is the vertical asymptote. It's 2, and the horizontal asymptote also there by 1. So so this is the horizontal asymptote, and the vertical asymptote passes through the point here, B. So now I can just substitute the value of B there, over here. So Y will be equal to 3 over X minus 2, okay, minus 1. So we know that, therefore, we can say therefore P, okay, equals to 2, and T equal to -1. So these are the value of P and T. Okay. Then let's see now. The next question is which question is that? Now we're doing question 5.6. The question says write down the values of X for which f of X times G prime of X is greater or equal to 0. Well, this is interesting. Now we're going to, I want to move my board over here. We're going to do question 5.6 now. 5.6. The question says, so now we need to prove that f of X multiplied by G prime of X, this is greater or equal to 0. Well, f of X was given by, it has the value of x squared, no, negative x squared minus 4x, okay, plus 3. Let me double check the function. I want to move, yeah, negative x squared plus 4x minus 3. Negative x squared minus 4x plus 3, yes. Now, and then this is f of X. So we know that these, okay, first, before even start answering this, I can go over here. This can be true only if f of X is positive and at the same time, okay, G prime of X is also positive. Okay, because positive times positive make positive, or f of X is negative. At the same time, G of X is also negative because negative times negative will make positive. So this one is positive where f of X. We can look at the graph and see where it is positive. We can use the graph or we can factorize. Okay, even for the graph, we can see that it is positive in certain interval. Okay, let's see. So, oops, if I look at the graph here, it is positive when X is in between this value. Only this part. So now maybe let's work it out. We can work it out. Okay, let's work it out. So I'm saying this will be positive and that's also positive. So we're gonna set it equal to 0, okay? To find the critical value. Plus 3 equal to 0 to find the critical value. So this means, okay, I can just move, reverse the order, okay? This means, or if I times by -1, this equation will be x squared plus 4x minus 3 equal to 0. And then, no, excuse me, initially f of X was, it was negative x squared plus 4x minus 3. So, excuse me, it was initially positive here. So positive, if we set it. So this one will be negative. Yeah, it's going to be negative here if at times by -1. Now let's factorize this I did it because I wanted to factorize. So if I factorize, put x here, close bracket, open bracket, then I put another x here, close bracket, equal to 0. Now, I'm gonna look at the constant term here, which is -3, and I write here -3, and then the factors of 3 are just 1 and 3. How can I get -4 if I have like -3? It's only if I do -1 and -3, because -1, -3 will make this -4, the middle term, and -1 so it's not exactly that. Did I write this correctly? Initially it was -3 there, yes, yes, and then it must be positive over here. Oh, my apologies. Over here, I think I made a mistake. Let me rewrite the thing. I'm not writing the thing correctly. F of x was initially -x² plus 4x² minus 3. It was like that. Now, we're going to set this equal to 0. If I need to find the critical value, to find where it is positive actually. Set is equal to 0, meaning we're going to times the whole equation by -1. So if I times by -1, this becomes positive x², -4x, and then positive 3, like that, equal to 0. Now, I'm going to look at the constant value here. This constant value here, positive 3 there. So I write here positive 3. Now the factors of positive 3 are 1 and 3. Now, if I need to get -4, the coefficient of the middle term, this is possible if I do -1 and -3. Then over here in the bracket, I can just write x, and then x in the bracket like that. And then in the bracket, I write -1 and -3. So this is equal to 0. You can double check. -1 times -3 makes positive 3, and -1 minus 3 makes -4. So this is correct. Now, I'm going to draw the number line. So to check where I get it right, I mean to check in which interval f is positive. So if I draw my number line there, we have like a point there and there, like this means 1, and then that's 3, because if we calculate here, this means that x is equal to 1 or x is equal to 3. Remember, these values are not the solution. Those ones are just the critical values, okay? Those are the critical values. The critical values are the values that determine the boundaries over which the interval is positive or negative. So we need to find the sign of each interval here. Now, in the first interval here, what should be the sign from negative infinity? If I pick up any value below 1 here, a number like 0, if I sub 0 there for x, I want to get -1 times -3, which is positive. So over here, we have like a positive sign. Now, in between 1 and 3, for instance, I need to pick up a value here in this interval, and then I get what? If we take a number like 2, for instance, we're going to get negative, because if we sub 2 there and 2 there, we get positive times negative, it's going to be negative. And then obviously this side is going to be positive, because if I take a number like 4 in this interval, 4 minus 1 and 4 minus 3, it's going to be positive times positive will make positive here. Then then I'm going to look at in the other interval for g prime of x. G prime of x. Well, I know that g prime of x will be negative, but let me prove it to you. G of x is given by, we did find that g of x was 3 over x minus 2 minus 1. So g prime of x will be the derivative of 3 over x minus 2, okay? And then the derivative of 1 there. So this is just 3 derivative is like writing like 3 times x minus 2 to the power of -1 derivative, and then the derivative of the constant is just 0. And now over here it's just, this is like 3 to the power of okay, the derivative will be -1. It's going to be -1 times -1 times 3, okay, because the exponent get down, times 3 open bracket x minus 2 to the power of -1. So this is like -3 x open bracket x minus 2 to the power of -2, which is -3 over x minus 2 to the power of 2. Now this function here must be negative strictly, because you have like x minus 2 to the power of 2. This will always be positive, and a -3 is a numerator. Negative over positive makes always negative. Now to get the answer over here, the value that we're looking for, we want, excuse me, it must be negative and negative. Okay, initially, okay, here we times by -1. So we times this function by -1, but if you look at the graph here, we times it by -1, but the initial equation was not this one, but this one, because here the u is like this. The parabola has a U shape, but over here the parabola has an inverted U shape. So there in the parabola here, it was negative in this interval, okay? Because if x has a value like lesser than, here we find that there is a value of 1 and 3 there. For x having value like less than 1, okay, and value like more than 3, f of x will be negative. So we're going to consider these values here negative, and it's negative over here. So negative times this negative will make positive. So therefore we can say, therefore f of x times g prime of x will be greater or equal to 0 if x is lesser than or equal to 1, because no, when I say lesser than 1, no, less than or equal, because, okay, less than equal to 1, because it says greater than or equal. So if you look here in this interval, lesser than this point, this part, because negative times negative make negative, excuse me, negative here times that's negative of g prime will make positive, and negative here also times g prime, which is negative, will make positive. So if x has the value of lesser than 1, or x has the value that are greater than 3. So these are the possibility, okay, for which we can have a product here greater than or equal to 0. So calculation here, then I will emphasize the calculation here were actually pointless, because we could just look at the graph. We shouldn't use this, because here we times in order to find the critical values, but it's not the original equation. So we don't really have to do this. What we can do for f of x, actually we are supposed to just look at the graph, okay, to see where f is negative, and then the calculation that we could do only would have been the calculation of g prime of x. And then we found that g prime of x is negative, and then we can just take negative times negative, that will make positive. So the only option here was this part, okay? Because here we have like negative times negative, of course this makes positive, this makes greater than. So if I look at the place that it was f of x was positive, like between 1 and 3, but g of x will always, g prime of x will always be negative, as we proved it here. It will always be negative. So this wouldn't be the correct option. The option was only this. As I say, calculation here will be pointless. You could have just look at the graph and then use the graph to find the sign of f of x, and then apply this property here with the calculation that you find with g prime of x, and determine which interval x is defined. Thank you.